All right, welcome to DevOpsDC, February 15th edition. For those of you who don't know, this meetup was actually formed back in 2011, so we've been going for 11 years. But this might be your first meetup, and everyone is still welcome. We're going to go through our meet and greet. We just did that for 15 minutes. We're going to go through some brief introductions and announcements, and we have two speakers tonight. Stephen Black, who's going to give us a brief history of Kubernetes, and then Brandon Mitchell, who's going to talk about the state of secure software supply chain. So very excited to have you both here tonight. As a reminder, we do have a code of conduct. It is still in play. We want to make this a fun and enjoyable experience for everyone here. So we just ask everyone to show each other respect and courtesy. And there are instances where we've had to kick people out of the meetups for rude or lewd behavior. So if you do notice anything, you can reach out to myself or the other organizers, either on Twitter or on DC Tech Slack, and we'll show you what some of those ways to do that are. And then you can just report it and we can work on a resolution. And you can read the full code of conduct at our meetup page there. If you have any questions or suggested updates, we're happy to hear it. Okay, so I introduced myself earlier, but I'm Victoria Guido. I'm Vice President of Operations at Pluribus Digital. I actually live in California now, but I moved during the pandemic and we've still been fully remote, and I still work in DC with Pluribus Digital. So I'm still here as long as we're virtual. We also have Trevor Bryant, who is working at Red Hat. You want to say hi, Trevor?
Hey. Turn everything back on here.
Okay.
Yeah, my name is Trevor Bryant. I've been part of the group. Wow, 2000. I feel like we've known each other forever, Victoria.
I know.
Pretty much. I've been part of the group for a long time, and they brought me in to help organize, I think, early 2018. But I'm generally the person that's more interested in just security compliance sort of things. But yeah.
Great.
And then my professional avatar, Kevin, is also that security cat that's generally just everywhere.
It's very cute. And then we have Christina. Oh, sorry. Did you want to say add more, Trevor? Okay.
Hi, everyone. My name is Christina. I'll be talking more about my company here in just a little bit, but that is my professional avatar. I shave that mustache every morning. And that is right. I have no Twitter, but I do have a Twitch. So you'll see that link in there. Looking forward to this. I've been with the group, or I've attended the group since 2018, and I've recently, well, not recently at this point, but now part of the organizing group since COVID. So that said, looking forward to hosting our very first speakers of the year. If you got to catch the one in January, we did a lot of planning and ideation to get to where we are today. Now we have a couple of events lined up for everybody this year, and we're looking forward to what else is in store for us.
Absolutely. Thank you so much, Christina. Yeah, for organizing a meetup in pandemic, it feels like it just started yesterday and like it's been going on forever. So I understand how you feel that. So last month we had a meetup that was all about planning for the year, and we made some pretty big changes. Things like you'll see, we have a new speaker request form. So that's out there in the chat. If you have something you think would be relevant to this group, please fill out that form. We'd be happy to talk with you and get you scheduled for later in the year. We also did decide to start offering sponsorships again. For virtual events, we just had sponsors give money to a charitable donation. So we'll have a sponsor pitch here in just a few minutes. But we are also considering a potential return to in-person events, which is very exciting for us. Sometimes we'll still have some virtual and some in-person events, but we are looking in the future months to have it in person. If you have any thoughts or feedback about that, please let us know, but it will be coming back up again. All right. And you all told us what you wanted to hear for the year. This is a little word bubble that we made. So if you're thinking about, would I have something to share that's relevant with this group? If you see that keyword on this word bubble, that means it probably is relevant. This is a very broad topic in tech. It's all about sharing practices with each other and making more automation, making everybody better at what they're doing. So there's lots of topics that could be interesting to this group, and feel free to reach out and ask us if you have any questions. All right, but Kubernetes was one of the biggest words on here, and that's why that's a big topic for us tonight. We wanted to deliver on what you guys were interested in. So with that, I'm going to give it over to our sponsor for the evening, which is Rhythmic Technologies, also one of the organizers for the meetup. So I'll give it to Christina.
Awesome. Well, thank you so much for that, Victoria. If you guys haven't seen already, all the really cool stuff is already mentioned in our meetup page, but I did want to start off with, we are a big, DevOps, as Victoria said, is a very broad word, and it's really the communities that come behind it. So with Rhythmic, we wanted to be just supporting a small community and helping another small community. And with that, as mentioned, we are donating $3 for every attendee in here. I'm almost going to count Evelyn's daughter to join in that number as well. But we are donating $3 to biteback.org, which is an organization that helps adults get more computer technical savvy to enter the workforce for $3 per attendee. But there's more. There's more. I'll be putting in the chat a little survey. If you could just take a moment and fill it out, we'll be donating an additional $5. And I was just telling my colleague here, because we have a small number, and I feel like $3 per 23 heads, 25 heads isn't all that much. So we're going to throw $100 at default at it. And hopefully we can beef up that number with some of the survey signups. But that said, Rhythmic Technologies is a full service IT provider helping businesses thrive. If you have any questions, you can always ping me for that. But we know why we're here, and we can't wait to see what we have in store for both of our speakers. If you have any questions on Rhythmic Technologies or even Bite Back, I'll be putting those links into the chat. And again, we're a small community trying to support other small communities. And that's really what thrives in DevOps these days. So thank you so much for this opportunity to DevOpsDCs for allowing us to sponsor, and we can't wait to see what we got the rest of the year. If you have any questions and if you have any feedback on later today, please feel free to fill out that survey and sign up for our newsletter to beef up that donation number. All right. Thank you so much for everybody for being here.
Great, thank you, Christina, and thanks for sponsoring. I think Bite Back has a really wonderful mission, and I'm excited to support them as part of this being in the Meetup organizer. If you want to keep the conversation going outside of this event, if you're not already on DC Tech Slack, get on in there. It's a really great online community, and there's a hashtag DevOps channel. Also on Baltimore Tech Slack, if you're out that way. So you can ask all kinds of great questions. There's lots of great people on there, help you with your problems, vent about different issues, all types of things going on. We also do have a LinkedIn group that we just started. So if you're really active on LinkedIn, you want to join that group, you can follow that link there. And of course, keep connected with us on Twitter. We generally try to tweet about the events, usually more than one day before the event, but sometimes it is right before, and it's just in time tweeting. So lots to keep the conversation going afterwards. There are also lots of great tech events going on over, and there's lots of great virtual events happening now because of COVID. So you can check out how top tech companies are addressing diversity and inclusion, lightning talks interviewing for engineers, getting to know Git. We're executing your first agile transformation. So lots of great topics going out there. And if you have any other events you think that other people here might be interested in, feel free to share that in the chat, and we will send it out in a follow-up email after the event as well. So yeah, feel free to chime in there on that. So stay in touch. If you're interested in sponsoring a future event, giving a little 2-minute pitch, just like Christina just did, and helping with a charitable donation, you can go and fill out our sponsorship form. Once we get back to in-person events, we're going to open that up for hosting and for food and drinks. But for now, I think that form is geared towards virtual ones. We also have speaking opportunities. I think we need to actually update the link to that slide, but the link that Christina just shared in the chat is correct, earlier up in the chat is correct if you're interested in speaking with us or for us. We also have an email address. It's meetup@devopsdaysdc.org. If you're not familiar with DevOps Days, that is an international conference series, and the DC version has a lot of same organizers that run the meetup. So we actually use that email address from them, but not to be confused. And check us out on Slack as well. So thank you for joining us. With that, I will start off with our speakers, and I'm going to stop sharing and ask for Stephen to go ahead and kick us off from Rhythmic Technologies on the history of Kubernetes.
Thank you, Victoria. Let me share. Okay. Is it sharing PowerPoint?
Yep.
Excellent. So, hello, I'm Steven, and I rock with the good people of Rhythmic Technologies. We do a lot of things, including working with several different flavors of Kubernetes. And we've actually been using the tool since 2014 before the 1.0 release. So I've only got a few minutes. I'm going to jump in and we're going to go chronologically, history of Kubernetes. So the word actually dates back to about 400 BC. The ancient Greeks needed a word for the person who drives their boat. So, you know, if the idea of a boat and a boat driver are unfamiliar to you, I have pictured a modern warship here with a Kubernetes at the helm. Kubernetes is often abbreviated K8s. That's because the word is 10 letters long and they just substitute an 8 for the middle 8 letters, or Ubernetes. So Ubernet, 8 letters, Kubernetes, 10 letters, it makes sense. A lot happened in between those ancient Greeks and before Kubernetes. So I'm gonna try to focus on the important things for the genesis of Kubernetes. One, the internet happened, and if any remember, AOL was around. All of a sudden, systems became more distributed and API driven. Amazon parlayed their extra compute power into this totally new service, which are consumed by APIs, and the cloud is born. Docker comes out with an adorable whale mascot named Moby Doc, not pictured here. I assume this is one of Moby's friends, but they find. Thank you, Brandon. You learn new things every day. But they finally brought containers to lay developers like you and me. So the cool thing about Docker was it makes it easy for anyone to download Docker and start building containers on their local laptop, and then they can ship that container image to a container registry. So they can run the application, or maybe another developer wants to collaborate on an application and can then use that container. So Google at this time also comes out as a verb. They're pretty big. They developed Borg. If you're wondering what the square in the bottom right-hand corner of the screen is, that's a Borg ship. It's a different kind of Borg, but a Borg ship nonetheless. And the cool thing about Borg was that it took containers as the building block of applications and kind of stitched them together. Like, it took care of all the resources, all the networking, all the finding actual compute power to run the container, found the containers from the registries, pulled them down and got them all working nicely together, and then would continue to make sure those services were running. So really cool stuff. Now, you're probably thinking that, wow, that sounds cool, Stephen. How do I get one of these container orchestrators like Borg? So at that time, there really weren't any open source ones. But you are in luck, because at DockerCon 2014, a bunch of them were announced. Some were proprietary, like Facebook's Tubleware, which is now Twine. And there were other incumbents. So Docker had their Docker Swarm, and there was Mesos, which was a really hot orchestrator at the time that wasn't really built around containers, but was cool nonetheless. Google announced that they were going to open source a totally new container orchestrator and dubbed it Kubernetes. Originally inside of Google, it was actually dubbed 7 of 9. And if you're wondering who the lady is pictured in the middle, that is 7 of 9. She's a Star Trek character. But Kubernetes was built on what Google had learned running Borg. It set itself apart from the other container orchestrators by being open source, being API driven, and having a really nice declarative layer on top. And if you're wondering what that code looking stuff is on the right side, that's YAML. And if you work with Kubernetes, you work with a lot of YAML. It's the declarative layer on top. At the time, though, Kubernetes was kind of hacked together. It only supported small stateless applications, and was still hosted in a Google GitHub repository. So people had to actually sign a Google contributor license agreement. And that wasn't so cool if the contributor maybe worked for Microsoft or a competitor of Google. This changed in 2015, though, when the CNCF was announced and Kubernetes became its first project. And during this time, the number of contributors went from a few dozen to several hundred. So in the software world, this could be considered going viral. Kubernetes caught on fast, and it had to mature fast in order to meet the demands placed upon it. So in 2016, 2017, we saw the phenomena that was Pokemon Go emerge. Pokemon Go ran on Kubernetes. So Kubernetes expanded beyond just these stateless little apps, but started supporting persistent volumes, and so stateless apps. It had added security features in the form of RBAC, and network policies. It started to support thousands of nodes rather than a few hundred, and the contributor base to Kubernetes scaled to thousands of contributors as well. It was the driving force behind a lot of the standardization in container technology that comes later with the container runtime interface, the container network interface, and then the container storage interface. The Kubernetes community and the ecosystem go absolutely bonkers at this time with projects like Helm for packaging Kubernetes applications, Fluentd for logging Kubernetes logs, Containerd is an alternative to Docker, another container runtime, among others. Also in 2017, AWS released their own flavor of Kubernetes, EKS, Elastic Kubernetes Service. And this was big because AWS was a holdout on Kubernetes. They had their own container orchestrator platform, yet they couldn't help but release their own Kubernetes offering. It had just become that big. So Kubernetes at this point hadn't just become like a great container orchestrator, but it really became like a common API for defining cloud native applications. There are a lot of different clouds and there's a lot of different applications that can run on the clouds, but Kubernetes has become kind of a lingua franca that you can use between these different clouds. You can use the Kubernetes primitives to define an application and with not too much modification, run it on a different cloud like Azure or AWS or Google, or even on premises. So now what I'm going to show you next is a little bit unorthodox. Kubernetes is a project with a lot of personality, and I love that about it. Some of the releases have logos, and I've used the next part to really just collect all of the logos, maybe grab a few key features from that release, but really to bask in the glory of the logos. We're going to start with my all-time favorite, which is 1.10 release, the Left Shark release of 2018. So version 1.10 was codenamed Left Shark after the Shark and Maverick backup dancer who ended up being the star of Super Bowl 2015. It was a really popular meme, I guess, with the Kubernetes developers at the time. Kubernetes also stabilized some key features like DNS and storage at this time. And if you're wondering about that Super Bowl, you can see Left Shark here. He's on the left. He is messing up his dance routine like the Maverick he is. So release 1.11 is release 11T1, a long expected release. Core DNS gets GA'd, which is actually another project of the CNCFs, and CRDs get multiple versions, but also the logo, if you don't recognize it, is a reference to The Hobbit. So release 1.12, it's dubbed a next iteration in the evolving stable distributed system. It takes its logo from Conway's Game of Life. As you can see, the Kubernetes logo is there. Azure also gets a ton of support here. You can use Azure VM scale sets now. So they're like Azure auto scaling groups, if you are familiar with AWS. 113, dubbed the Angel release. I didn't know this, but apparently the number 113 is like some superstitious special number, and it's an angel number. Kubeadmin, it's a tool for managing clusters, gets GA'd. 1.14, the first release of 2019, it is dubbed Kubernetes. As you can see in the logo, there's some kitties looking at the Kubernetes logo. They GA'd Windows nodes, which I still have yet to meet somebody who's using Kubernetes for Windows containers, but they did it. Version 1.15, it gets its logo from the show. It was like Game of Thrones, or I don't know, it was a silly show. Anyway, it was dubbed the persevering release. CRDs, which are important later, if you've been using Kubernetes lately, the hot new way to package applications is with operators. CRDs are critical to operators. Kubeadmin also gives a pretty cute little logo. 1.16, one of my personal favorites. Those CRDs, and I'm sorry, those are custom resource definitions. They get GA'd. The container storage interface is an alpha, and I can only assume that this logo was inspired by Olive Garden. Also in this release, a bunch of the APIs get removed, deprecated APIs. So if you are a maintainer of a chart, this was a particularly problematic release because it actually meant you had to change things. 1.17, also dubbed the chillest release. If you're wondering what that animal on top right there is, it is a capybara. It's the world's largest and probably chillest rodent. The CSI is now in beta, and cloud provider labels are a thing. And I can remember the first time I learned about capybaras, it was watching the Wild Thornberries, and they were eating capybara burgers. Cool trivia. 1.18, first release of 2020, it gets its logo from the Large Hadron Collider, a bit quirky. This one, at least as of Saturday, is the latest version supported on AWS in their EKS. So Kubernetes moves really fast. They are constantly churning out new versions every couple of months. AWS doesn't ever like to sunset things yet. Early 2020 is the latest release you can get for Kubernetes on AWS. It was dubbed Fit and Finish. 1.19 is cute, accentuate the positive. This one's cool for cluster administrators because no longer do you have to update every 9 months. You can wait a year between updates. So previously the support window was only 9 months. Ingresses get officially GA'd, even though they are already used everywhere. Also, I've had this argument internally. I'm not sure what the plural of ingress is. I think it should be ingressi. I'm told ingresses. If you have an opinion, please, let me know in the chat, especially if it's a different opinion. 1.20 is the raddest release. So this is Humphrey, and he is a blep. Humphrey is a cat, and a blep is when an animal sticks his tongue out, but forgets to put it back in. Humphrey's blep is permanent. So he just runs around with his tongue out. Docker shim gets deprecated, and I forgot to mention this at the beginning, but Docker was pivotal to Kubernetes at the beginning because Kubernetes orchestrates containers, and the containers it would orchestrate were Docker containers. So they are changing that from Docker to Containerd. And this is the first release to start saying, hey, don't use Docker anymore. 1.21, power to the community. They stabilize some stuff. You can make secrets immutable. They are starting to release IPv4, v6 dual stack, which is cool because I guess IPv6 is actually a thing. We were supposed to move to it years ago. Also, pod security policies, which are pretty widely used, get deprecated in this release, and they're going to get replaced later. In 122, reaching new peaks. A lot of beta APIs get removed. So this is going to be like release 1.16, where if you have a Helm chart, you're going to have to make updates. 123, this is the latest release. It was dubbed the next frontier. The dual stack IPv4, IPv6 ingresses get GA'd, and pod security is in beta, which is the thing that's supposed to replace pod security policies. Also, the logo comes from Star Trek, which harkens back to Kubernetes origins. 1.24 is currently in the release. There is no logo or name for it yet. I'd like to think they're gonna have a fun logo like this picture here. And if they're taking votes for the name, I think it should be the Reckoning of Docker Shim. They are removing Docker Shim. So from 1.24 onward, if you want to use Docker commands in your Kubernetes charts or in your pods, you're going to have a bad time. You now have to deal with the container runtime interface and containerd directly. And that brings us to the present. And I wanna thank you all for listening to my ramblings. As you can see here, this is Rhythmic Technologies. They are the people who let me play with these toys, and they pay me to do it. If you have any questions about them, hit Christine up in the chat. She's wonderful.
Thank you, Stephen. That was great. I learned so much about Kubernetes and pop culture. So who knew those things were so intertwined? I really appreciate it. All right, so yeah, all of Stephen's contact information and his GitHub is shared in the Slack by Christina as well. So if you want to talk to him after this, you certainly can. Next up, we have Brandon Mitchell, who's going to talk to us about software supply chain, if he's ready.
I was just going to do the survey, but I can be ready.
Survey is good too. Yes, do the
Survey
survey.
was good.
Yes, Rhythmic Tech is going to donate for Bite Back, and it's a great cause. So.
But yeah, I can jump on.
Sure.
So I am legally obligated to mention that Docker itself isn't deprecated. It's just the Docker shim. Docker pushed out there a while back. It's been a while, but when the whole swarm was going on, they basically took a whole chunk of their code base that was running containers and spun it off into containerd. And so Docker uses containerd, Kubernetes uses containerd, a lot of other people use containerd. It's a great underlying platform we all share. So you can still use Docker, but inside of Kubernetes, containerd. So that's my legally required sales pitch, because on my background, I am a Docker captain. And so I have to say good stuff about Docker. That's also why I know the Molly trivia as well. So that's who I am, Docker captain. I got that after answering way too many questions over on Stack Overflow. And I work for a company called Boxboat. They got acquired by IBM. Oh, it's been a little over 6 months now. And so now I just got rebadged and new company sending my paycheck, all that good stuff that comes along with it. And in case you missed it on the title slide here, we're going to be talking about the state of the secure supply chain. So enough of all the little blabbering about there. You'll see on the bottom of a lot of the slides, I've got my Twitter handle, sudobmitch, and from there you can find these slides, everything else. I'll also throw a link at the end. All these slides are up there for anybody to look at later on if I go too quick. So what are supply chain attacks? So before we talk about securing, we need to understand what we're securing it from. And attackers have a whole lot of methods. I'm not going to read off the whole list. You can kind of look through there if you want to. But the one we're going to try to solve today, at least, or look at and address, is the last one here, which is the supply chain attacks. And those supply chain attacks, I like to compare it to a physical attack. And the one I look at is the Colonial Pipeline. We saw that one hit us. Was that last year, year before? Time is kind of confusing now with all the, pandemic timelines. Things get stretched oddly. The Colonial Pipeline, we looked at, if I tried to compare this to what an attacker would try to do, if they tried to shut down the entire transportation network, they could try to go after each vehicle individually. That would be kind of a pain in the butt. There are a lot of cars out there. You don't want to try to go after every single one of them. They could try to go after gas stations. That would be probably almost just as hard. There's still a lot of them out there. You could go after the pipeline itself, but in your Colonial Pipeline, that's your hardened production environment. You've secured that one pretty darn well. And so instead they go after the reuse password to the VPN interface to the billing system. It's the soft underbody upstream system that everything relies on. And if they can attack that, Colonial Pipeline says, oh no, everything's bad. We need to shut the whole pipeline down because we can't bill our customers. And so they shut it down for them. So that's what we're looking at with supply chain attacks. We're looking for those upstream dependencies or our build infrastructure, something before we get to production that can just ripple right through and it just gets taken right through to everything else. So as we're looking at this from a software perspective, we kind of go to this picture on the right where everything out there is kind of all dependent on that one lone project that's somewhere that's one person is developing. I'm not sure if this picture came up before or after the Heartbleed attack, but that was OpenSSL that everybody depends on, that you just forget that everybody depends on it. Well, you might know that everybody depends on it, but you might think there's a whole team behind it. And really, it's just the one lone developer out there by themselves. So we're trying to find these systems out there that are like that and trying to correct it and just be more aware of some of these things. This has been coming to the news a whole lot. So we see people showing up here because this is getting more and more popular. Dependency confusion attacks hit us a while back. That was in like NPM and I think Python as well. There was not a very, you weren't certain when you're pulling stuff, whether you're pulling from your local private repos or from a global upstream repo, because it was just one common namespace for everything. And so people would find these names that they're like, well, I see that someone like a Netflix is using this private repo out there because I can see it in some code they've committed or shared somewhere. And so what if I registered that private repo out there on the big global namespace and all of a sudden that code just got pulled in the Netflix build system and started running over there? That was not a good day. So that's one kind of supply chain attack. Other ones out there, the big one that got everybody's attention was the SolarWinds attack. That's when they found their way into the build system itself and were able to get that code signed by that secure build system, shipped out to all the customers, and that stuff was running as basically the root of the network. It had full access to everything. It was not a good day. And most recently, Log4j, I wouldn't even consider it a supply chain attack, but it got our attention because when we realized how fast this was throughout the network, Log4j was all over the place. There was a lot of Java code out there that was compiled against this. And we realized we needed the same stuff we're going to talk about today to solve this stuff, which is things like the SBoMs. We need to find a way of where is this deployed throughout our whole infrastructure. We didn't have a good way to look at that. So it's been in the news. White House comes out and says, yeah, we're going to make an executive order here. You guys got to fix this stuff. And so suddenly this became popular. Before then, I think there are a lot of companies that figure someone else will solve it and then we'll just tail along behind them. And then the White House says, sorry, too bad, you got to solve it no matter what. That gets people's attention. And yeah, this isn't new. Way back in 1984, Ken Thompson, who, if you look back through a lot of literature, some of the originators of Unix and C and a bunch of these other things, I believe he was in that whole group. He was writing a white paper titled Reflections on Trusting Trust, where he was saying, what happens if someone makes a compiler that just sees when it's compiling itself and just replaces itself with some bad code and sees when it's compiling something else that's really critical to your infrastructure? You know, back then it would have been Telnet. Today, think of SSH or something else you get into all the servers with. And it just injects a backdoor. And then you just take that code out of the source code, but it's in the compiled code. And everybody, when they take a compiler, they're grabbing the pre-compiled compiler down from upstream. How would you ever know something like that was in there? Excuse me. So we've been looking at this for a long while and still trying to find a good solution to this. And in our production infrastructures right now, the supply chains, they get a little complicated. What we're going to try to build is an infrastructure that looks a little bit like this picture on the right, where we need to validate our inputs. That's kind of step one. We've got a lot of source coming in from outside, a lot of stuff that we're building internally. We need to do the two-person rule. Everything we build needs to be verified, but also all our external inputs, we need to scan them. We need to make sure that we're pulling in good, safe source code from upstream. And that's a challenge because developers, those add one line of code to their stuff and they just pull in an entire tree of external dependencies. And now we got to start scanning that. So it's an asymmetric problem there. It's not easy to solve that one. The infrastructure itself, I kind of put this whole little bar under it, just saying we need to harden the whole build infrastructure out there, from grabbing the libraries all the way through to the distribution stage there, which is your entire build pipeline. So we need to try to harden that infrastructure to make sure that no one's going in there and breaking that. It's something that I think a lot of places don't do. The build infrastructure itself is a little bit of a Wild West. It's usually on the development side of the house, but what comes out of this goes to production. So we need to secure this as if it was like a production environment, because it's just that kind of critical. If someone goes in there and hacks that, that's getting pulled right into your production as if it was anything else you trust. We need to verify that build process. There's a whole lot of steps there that says, how do we know we actually did what we said we were going to do? And that's kind of a hard question to answer. And so we've gone through a whole bunch of those cases out there of trying to solve that, trying to build attestations into all the different compile steps that we're doing, all the different build steps to verify each thing. We actually pulled that same source code. We actually ran all the tests, getting that information passed along. We need to sign the result. And so we need to know that this came out of our build infrastructure. So we're adding sign in here. And we need to distribute this stuff. And when we distribute, we're not just distributing, in today's case, we're talking about container images. We're not just distributing those images out there. We're distributing the signature because you need to pass that along with the image as you deploy that. We need to pass along stuff like the SBoMs. So we'll talk about what those are in just a second. We've already handed that a whole bunch. Any attestations and other information, all that metadata needs to travel with the images it goes across so that you can check that, look it up, make sure that it passes all your checks before you run this in production. And the last step down there is that image controller into production. That's kind of your last gatekeeper that says, make sure that somebody actually did all the stuff they were supposed to do, passes all the checks, the security department scan this stuff, it says it's good. It's got the right signature that says it was built by our trusted infrastructure. Everything looks right. And then you can ship it out to production. So a lot of moving pieces in here. And this is not, when people look at how they secure supply chain, it's not just one little product you can buy and just click a box and make it happen, unfortunately. There's a lot of moving parts. So what I wanted to talk about today was a bit of the state of the supply chain, because there isn't any one tool that does this. And a lot of this stuff is under very active development. And so I think people are looking for, okay, I've got the White House executive order right now. How do I solve this? There are pieces in here that solve pieces of the problem, but the holistic end-to-end, I don't think it's been solved yet by anybody yet. I think we're still putting these pieces together. And so a bunch of this is a call to action. If you see things in here or I say it's not done yet, it's because we're still actively working on it and help wanted. This is all open source. So go out there and help join in. So the first tool I want to talk about here today, SBoMs. These are the software build materials. Think of these as like the ingredients label on your application. So it tells you all the different libraries you've pulled in externally, tells you what version of the source code, what git commit you checked in to build this code. So all the details someone needs to know to look at this code and say, does this have this malicious version of log4j in it? You could look at the SBoM and find that out. And so that's what we're trying to generate here. Two competing standards out there, SPDX and CycloneDX. They came at it from opposite angles. SPDX came in from the licensing side from Linux Foundation because they were worried about, do we have a version of GPL that we don't want to inject because all of our code is Apache 2 licensed? And so they didn't want to have like a copyleft license go in there and corrupt all their legal terms. CycloneDX came from OWASP, so they were concerned with security first. And so two competing standards, but they're both kind of coming together. The difference is just what's optional, what's mandatory between each of them. And depending on what you're doing, you might want to have your own list of things that you want to have mandatory within your software build materials. So as you do this, look at, it's not just generating it. It's not just building the SBoM. We need to figure out how can we deploy this. We need to get this all the way out in production or out all the way out to wherever we ship our image. And then we need to ingest it. We need to say, okay, we've received this SBoM. We need to do something with it. We need to be able to query it. You know, it doesn't help you if you've got a whole file system full of these SBoMs and then someone says, where's log4j? And you're looking at the whole pile of SBoMs. You're trying to figure out, where is it? I don't know. So we need a query interface. We need some kind of database tool to do that. We need our scanning systems that are doing our vulnerability scans to be able to look into this SBoM data and query that data at a lower level. Because right now, a lot of the scanners are just looking at what's on the file system, inside our container images, what packages were installed on the operating system. They're not getting down to this level of what libraries were compiled into the compiled code itself. So this is where we can get a lot more advanced if we start using this data. So to everybody saying SBoM is a solution, it is, but it's only step one of a three-part solution there. So there's still farther to walk. The next step I want to hit on, attestation. There are a couple tools out there in the CNCF area right now that are very popular in this one. One is in Toto. And what it's doing is it actually tells you for each step of your build, the person that runs that signs and says, here's my little attestation of what I did. It says, here are all my inputs. Here are all the outputs that I generated. Here are the commands that I ran to do that transition from input to output. And then they sign it with their signature. And what it gives you is a way to verify that nobody man-in-the-middle to any one of your two steps. It's not the greatest. I think there's some promises that get thrown out there to say this is going to verify every little step of exactly what happened. Yes, as long as your build server wasn't hacked. If the build server gets hacked, the attacker has access to that private key that can sign the bad data just as easily as you're signing the good data. And so it doesn't guarantee that your server itself wasn't hacked or that there wasn't a bad command thrown in there. But as it goes from one machine to the next machine, if someone man-in-the-middle is that, you now have some cryptographic guarantee that nothing happened in between there. And so since it doesn't guarantee the machine itself wasn't hacked, we look to the next level here, which is Spiffy and Spire. Spiffy is the specification, Spire is one of the implementations of it. And what this is looking at is how you can provide these little short-term keys to attest the workloads and the machines those workloads are running on to know, did we have a trusted machine that built this thing? And so you get these little short-term keys. You can then use that for signing in toto. You can use that for doing all kinds of other signatures and verifications around there. I use them for OpenID Connect, talking to Vault System and get a certificate to talk to that environment. A lot of different ways you can use them. And from there, you get that guarantee that this was run on a machine that your infrastructure says is trusted. So there is this hardened Spire server outside of your cluster, hopefully, that the security team has managed and set up properly. And it's just giving out this trust and saying, okay, this machine came and talked to me. Let me verify that node is really who they claim they are. Maybe you're looking at the TPM. Maybe you're looking at other kinds of stuff in the Kubernetes cluster environment to diagnose what kind of node that is. And then the workload on that machine, you're verifying, okay, that container spun up. Let me look at the namespace that container is running within in the Kubernetes environment. Let me look at the service account that it's running with. It can give out that trust and verification that this is coming from a workload that you actually trust in there. So between the two of those, we get a little bit more confidence of what we built. Once we get the confidence of what we built, we need to start signing it. And this space gets pretty busy out there. We've got a lot of signing going on in terms of like KMS and HSM. Those are the key management service, I believe, and the hardware security module. That's if you're doing signing, you want to sign through an external system. You don't want to actually give out your private key to anybody. And so you go to either hardware or to a cloud service out there and say, sign this for me. And it looks and says, do I really believe that you're someone that should be signing this stuff? If so, yeah, you passed all the checks there. Okay, here's the signed data with my key. And the key itself never left that external system. So that gives you a lot more security by doing it that way. Vault itself, they do a lot of their own secrets management. They've got a whole system for this that comes from HashiCorp. The one that I like from them is they've got a transit plugin, which basically makes Vault into like a KMS service. And so I've done some integration out there that takes Vault, adds in the login through OpenID Connect, and then uses Spire's interface for OpenID Connect to say, only give out access to do signing within Vault to the machines that have that little Spire verification in there. So I now only sign stuff from a trusted workload in the cluster. From there, we've got a handful of signing solutions out there. Tough itself is the backend, what we saw from Notary version 1. It's the update framework. I believe it's New York University is the group that pushed that out there. They've got a whole hierarchical list of how they keep track of who's got what key, delegating keys out to the right groups, and then making sure a whole bunch of different attacks aren't possible with their whole design of how they manage their keys. They avoid rollback attacks, replay attacks. They handle revoking keys or even revoking an individual signature. If you thought back to what was the SolarWinds attack, Microsoft never revoked that key for like months afterwards. That was signed for the SolarWinds. They couldn't revoke the key because that same key was used to sign a whole bunch of other code that was already out there in production that users were using. And so something like Tough can go out there and say, I'm just going to revoke the one signature for this one piece of software, this one application, because it was signed bad, but the whole rest of it we can still trust right now. This is the kind of tool that gives you that possibility. Then we've got a handful of tools out there, Cosign and Notary version 2, that are looking to revamp the container image signing space. And so Cosign, it was a Project SigStore. I think it was Google, probably Red Hat, a couple others that were all within that project. They pushed for this one. And it's still very active in development, but they've at least got something out there that is usable. And that's kind of a nice thing to have in today's day and age. So Notary version 1, I wouldn't even consider it usable. They had a lot of challenges in there. Cosign solved a bunch of those challenges, still very early out the door, but it gives a way to do this signing of your container images. And the option there is the Notary version 2, which they've still got a ways to go. They're still working on it. It's coming out from Microsoft, and AWS have been doing a lot of the coding behind that one. And the challenge they're going to have is they're requiring a forked version of the container registry. And so it works on Azure, but I think just about everybody else, it's not going to work on their registry just yet. So that's their big challenge they need to solve before I think we'll see that one even considered for adoption. And I've listed a few other projects in there. I won't delve too deep into a couple of these, but there are a whole bunch of different projects in the space for how we can do this. The last area I want to hit on, though, is the image control. So this is just before we start hitting the production environment in Kubernetes. This is that last little gatekeeper, and conveniently enough, that is that first title for the first project there, where we're saying everything before we run it in production, let's make sure that we really want to run this workload in our production cluster. And so the OPA gatekeeper comes, the OPA was Open Policy Agent. They have a language called Rego that you can use to define your whole policies. And then Gatekeeper takes OPA and extends it for how you use that for a Kubernetes image controller. And so they've been adding some capabilities in there for how they can use this for image signing or verification of signed images. Similarly, Kyverno is another one of the competing image controllers out there. And they've also been adding capabilities in for that one. What I've been seeing is the Cosign project has been adding a webhook to their project so that a lot of these other tools out there can just call the webhook from Cosign to do that verification. So we're seeing that capability getting added into some of these tools. And the last one, Connoisseur, is just another one is signing verification tools. They're trying to be the universal one that just says, we'll do just image signing, no other capabilities, where like Gatekeeper and Kyverno are more general purpose. You can check all kinds of stuff with them. But Connoisseur is saying, we're just going to do just the image signing verification, but we're going to do it for no matter how you've signed your image, whether it's Nerdy version 1, Cosign, Nerdy version 2. They're trying to solve all of those. So between these, we've got a lot of different tools out there for how we can do the image control into production. And it's a developing space, so it's a busy space. And I want to mention a few groups out here, because if you're looking at this space, you're seeing a whole lot of stuff under development. So I just kind of want to point you to some of the areas where some of this development is happening in more of the standards and spec area, which OCI right now, they're the ones that develop the whole container registry spec. So when you're looking at how you store Docker images, how you ship those Docker images around, they're maintaining the spec for that one. And it's mostly been a stable project for a long while. And then recently someone said, hey, we need to look at how we can start shipping other stuff to registries other than just container images, like the SBoMs, like the signatures and attestations, stuff like that getting up to the registry. So they've got a working group right now to see how they can start attaching other data to the image in a very loosely coupled way, which is kind of a challenge because everything in a container registry right now is content addressable storage. So you can't just add something under that and not change that digest for the content. So they're looking at how you can attach stuff after the fact to an image. It's kind of an interesting challenge. In the CNCF, there is a security tag out there, and they've got a supply chain working group. So a lot of the content from these slides came from that working group, what they've been working on that side. OpenSSF comes out of the Linux Foundation. They've got a whole bunch of groups working on security. I think I saw them getting a lot more busy after the Heartbleed attack because someone realized, hey, we need to start securing or supporting all these critical projects and start to secure them. So you see this coming out of the Linux Foundation. They're a very active group right now. And SALSA, they came from Google, which was the supply chain levels for software artifacts. They're trying to make this standard. So this is, I believe they got donated to OpenSSF for one of the groups out there. And what they're trying to do is just define how you can understand all of your different provenance for all your dependencies you have coming into your source code, and how you can define the provenance for your source code itself. And so kind of complicated word, but just making sure that you know what you built, where it came from, and you can communicate that to the other people. And that one's still very early on. They're still kind of trying to develop what that standard is going to look like. But the nice thing is they're building a tiered system. So you can say, hey, I've got this SALSA provenance level 1 over here. We want to try to get that to level 3, and you get a roadmap of what you need to do to get yourself up to a more secure level. So that was a whole bunch of projects on how you harden your build infrastructure. I want to take one slight detour here with a few minutes that I've got left and say there is another option, another little direction here, which is we can do reproducible builds. And what the heck does that mean? Right now, we've got the normal supply chain on top, where you say, let's harden this one path out here, make sure nobody can go in there and break it. Nobody can nobody can find a way to attack it. And invariably, someone will probably find some way to do something. You know, the people that are running SolarWinds, they knew their stuff. They were trying to make this stuff as secure as they could, and they still got hacked themselves. Reproducible builds looks at it from a different standpoint, though. They say, let's just build it twice. Do the exact same build a second time and make sure the outputs match. Make sure they don't change at all. And it sounds like a really easy thing to do. costs you double the amount of CPU time and storage and everything else, whatever you're using for your builds. The challenge comes in that it's a lot of the stuff we do is not reproducible. We think it is. A lot of people say, hey, I built my code, I built it a second time, it comes out the same stuff in production, everything looks good. You've got timestamps in your code. You've got externalities. So if you build things a week later, that Docker file that says apt-get update and pull the latest version of curl to do your build, it might get a different version of curl the second time it runs. You've got potentially host dependencies out there. So there are a lot of different things that can come into play here that you don't even think of a lot of times, where the actual bit level, byte level files, at that lowest level, they're going to change from build to build, and something goes in there, modifies it, and that just throws off the entire digest of your image. Everything changes at that point. Every Docker image build these days, from something like a Docker build command, none of those are reproducible because all of them include a timestamp in there. It tells you when you built this image, and that timestamp itself isn't reproducible. But let's say you solve that problem. Let's say you fix that. The nice thing is if an attacker comes in there and finds a way they can go in and break a little step out there in some way that you might not have noticed. Well, if you just did a normal supply chain, it will just go all the way through and you didn't notice anything. If the output says, okay, I built this, you built it, you signed it, that's your SolarWinds tech. That's something that just went out to production to all your customers. The other version of this, if we did reproducible builds, they would have to do that exact same attack to every place you're doing this build, because if you ever see one of these builds looks different from the other, red flags go off and something went wrong. So that's why I consider this the holy grail, but it's also very hard to do. And so I don't see a lot of people doing this, but I consider it the destination I'd like to see a lot of us get to. So if you want to look at that one a little bit more, reproduciblebuilds.org, that one's a great site to look at. And there are a handful of other groups that are looking at this stuff, like Nix and Bazel and Build Packs out there. A few other groups are looking at this. I've been looking at myself to see, is it possible we can potentially go back and take a Docker file and take a non-reproducible build output and do things like strip all the timestamps and turn stuff around so we can change it to become a reproducible artifact in the end. So that's been my little side project that I've been working on lately. So that was a whole lot of stuff. I probably blew through a whole lot of different topics. People saw a whole bunch of names there and didn't see a whole lot of content on the name. And this wasn't even an exhaustive list. There's a lot more than this that I didn't even cover. These were just the popular open source tools. A lot of them are over on the CNCF ecosystem. This is all very specific in container space. And so it's a complex process. There is no one tool is going to solve the problem for everybody. It's going to be a collection of tools. They all need to work together. And so this is a lot of this is just to help wanted to come out there and contribute. And we would appreciate any help that people can add into this. So with that, I'm going to throw a thank you out there. These slides, I'll throw the link out in the chat just after I stop sharing, but they're all up online. If people want to click on some of the links in there and find that project they're thinking that might help their problem, go check it out. That's all I got.
Thank you, Brandon. That was awesome. And if you put that link in the chat, then we'll share it out in the email as well. And I'll go ahead and I can stop recording.